how are you? Boleh dengar tak suara?
Boleh.
Alright. Okay. So what we're going to do today is we do some tutorials regarding on the current topic which is vibration, free, undamped and damped for 1 degree of freedom. Okay. So basically we have another 2 topics that we need to complete, which is force damped for 1 degree of freedom, and the last topic is about double degree of freedom, which is regarding on the free undamped for 2 degree of freedom. Alright, so before we start on the tutorials for this topic, we have a look at the summarize of the equation, the basic equation of this topic, which is, I guess this is very important for you to know, because some of the question is we use all these equations in order to find any unknown values. Alright, for example, the first one, what is our equation for omega n, which is natural frequency? Alright, so basically for some questions we are given the parameters of spring stiffness and also mass, or some questions also, yes, this is a recording. Some question also we are given in terms of G, or gravity and deflection. Alright, so jangan terkejut lah kalau setengah soalan dia bagi dalam bentuk G and deflection, because natural frequency is basically can be related based on K, M, G and deflection. Alright, number 2 is about the equation of damping system. Also this one in terms of satu lagi equation in terms of natural frequency dan juga zeta dekat sini. And then omega D, what is omega D? You must know how to find omega D, which is damping frequency. And also T adalah dia punya period of time lah. Alright, and then last one is about the ratio displacement between initial and a final displacement. Alright, and then this is our equation. Okay, so what we're going to do today is we are going to do some equations regarding on this topic. Alright, before we move further, any questions so far? Ada soalan nak tanya berkaitan dengan soalan ni, berkaitan dengan topik ni? Tak ada? Okay, so basically we have 3 types of, ataupun kita ada 3 methods that we are going to use, but not all the methods can be used, because the methods basically depends on the conditions. For example, if we use the method of potential energy and energy kinetics and energy, then that equation is only applicable for system without damper, isn't it? And if we use the method of equivalent system, alright, that one is only applicable for 1 degree of freedom. Okay, so basically for this topic we are going to cover on question number 3 for final exam, which is biasanya dalam final exam kita tak bagi a very specific which method that we are going to use. So basically normally kita akan guna topik nombor 3 lah, which is equivalent method. Okay, so let's we have a look this question. Okay, the system shown consisting of springs and dampers is displaced and released. All right, displaced and released. It was found that the amplitude after one cycle is 1/50 of the initial displacement. All right, determine the damper coefficient C. We need to find what is our damper coefficient of C. Okay, so if you look at this diagram given here, uh, we have more than one system of damper, spring, and also mesh. Alright. Okay, so apa yang kita akan buat adalah biasa kita akan guna kaedah equivalent method, which is we need to simplify our system, just simplify it in terms of single value. All right, single value. All right, so we have a mesh equivalent. You also have C equivalent, and this is K equivalent. All right, K equivalent. Apa masalah ni? Saya dah record ni. Saya dah record. Jangan risau. Kejap, saya check balik. Okay, so mana dah hilang dah? Okay, so saya dah record, jangan risau. Macam ni kita nak dapatkan C, then we need kita kena guna kaedah equivalent, paling senang kan. So macam ni kita nak buat. First adalah we need to choose which point we need to transfer all the system or all the values dekat sini. Kat mana yang paling mudah yang kita nak transfer? Let's say this is point D, dia tak bagi dah. This is point ni. So kalau kita tengok kat sini, you can paling mudah sebenarnya kita nak transfer dekat point D lah. Kenapa? Because if we transfer all the system to point D, then yang ni biasanya will doesn't change lah. So K2 dan C will be the same values. Alright. Yang kita akan ubah adalah we transfer all K1 C on point D, and also we transfer all the meshes we have. How many meshes we have? We have mesh A, we have mesh of disc, and also mesh of beam here. Alright. So first adalah we focus on the spring first. Alright, we transfer all to the point D. Alright. So for spring, what happened? How many springs we have? Kita ada dua kan? So spring for number one, this one. So how to transfer it? So as the center of rotation of the beam lies on point B, then our reference of the transition of K must be refers to point B. Okay, so what happened is that we have K1, we need to transfer K1 to here, then our K equivalent 1 must times with distance from B, which is L, isn't it? Which is L squared, alright, equals to distance from B to K1, which is K1 times with 0.5 L squared. Is that clear? 0.1, sorry, 0.5 L squared. Then from here we can actually find what is our K equivalent 1, which is K is given, isn't it? 2000. 2000. So cuba kira berapa K equivalent 1? 0.5 square bahagi 1 darab dengan 2000. Betul kan? Sekejap. 0.5 dapat berapa ni?
500.
500, betul? $500. 0.5, 0.51. Betul ke 500 ni? Sekejap. 0.5 square, betul lah 500 kan? Darab 2000. 500. So K equivalent 1 equals to 500. Betul? Ke salah equation dia? Kita tengok balik equation dia. Equation which betul kan? Okay, this one kan? Sekejap. Okay, this one. So kita kena guna A square over B square. So A adalah A kita adalah saya tersilap lah pula. Ambil yang second page, tak apalah. Okay, A kita adalah 0.1 square. And then B adalah 0.5, so betul lah. So and then K equivalent 2. K equivalent 2 adalah berapa? What is our K equivalent 2? What is our K equivalent 2? K equivalent 2 adalah 1000. Okay, 1000. So then our total K must be 1500, isn't it? 1500. Okay, 1500 Newton per meter. So that is our K equivalent. Okay. And then lepas tu kita akan ambil yang damper pula. Damper. So for damper, so what is our damper? Sama juga kan? So C equivalent 1 times with L square sama dengan C1 times with 0.5 square, isn't it? Is that? And then our C equivalent 1 must be, ataupun C lah. C equivalent 1 must be berapa? 0.5 square, 0.5 L. Alright, 0.5 square. So 0.25 C, isn't it? 0.25 C. Okay. And then for C equivalent 2 equals to C. Then our C equivalent must be 1.25 C. So that is our C equivalent. Okay. And then next adalah kita nak transfer all the masses we have. So how many mass we have? Kita ada mass A, we have mass of beam dan juga mass of disk C. Okay, so let's we have a look mass of A first. Alright, mass. So mass A, how to transfer?
Soalan C
Yes. Apa dia?
Soalan dia nak C
Soalan dia nak C. Tak nampak Tak hilang, kenapa tak hilang kat atas ni? Biasa dia hilang. Okey, dah hilang dah. Okey, soalan dia nak C. Determine the damper coefficient of C. So mass. So we transfer all the masses we have. So kita tengok yang mass A dulu. So macam mana kita transfer mass A to D? So as mass A ni dia bergantung kepada pivot point dekat C, then we need to we need to relate our mass dengan distance from point C lah, sebab dia bergantung kepada rotation about this. So macam mana kita nak buat? First adalah kita akan ambil M M equivalent 1, alright, times sama dengan, dia mesti sama kan, sebab yang ni distance bergantung pada this, so dia akan sama lah MA, betul, which is 4 kg. So no need to, kali ikut asalnya kita kena darab dengan distance, radius 0.25 L square, MA pun 0.25 L square. So then kita akan dapat nilai yang sama. Alright, so that is a first mass. Second mass is we transfer the mass of this. Macam mana kita nak transfer mass of this? The whole disk ni dekat point sahaja. So what is our equation of mass disk ataupun mass moment of inertia for this? IC equals to what? 1/2 m r square, isn't it? Okay, 1/2 m r square also equals to, kita nak samakan dia dengan m equivalent 1, sorry, m equivalent 2 times with k square. Alright, k square. So k dekat s, kita nak transfer di mass ni as a single point dekat sini. Jadi k ni adalah refer kepada radius ya, sebab radius sama daripada pivot C ni. So 0.25 L. So 1/2 m of this is 32 times with radius 0.25 L square equals to m equivalent 2 times 0.25 L square. So cancel out. Then kita akan dapat m equivalent 2 equals to half of mass of this lah. So which is 16 kilogram. Alright, clear? And last one adalah mass of beam. Alright, beam BC, sorry, beam from B to C, which is we are given apa? IB kan, IB untuk this adalah ml square over 3, isn't it? Betul. Beam untuk this, sorry, mass moment of inertia for beam bila mana point tu berada di hujung. Alright, so sekarang ni kita nak transfer all the mass, ataupun dia dah bagi apa ni? IO. IO tu apa? ml square over 12. Okay, so since kita nak transfer D mass beam ni dekat point D, then kita tahu rumus untuk beam IB. Alright, IB adalah ml square over 3, isn't it? Betul. Sebab rotation berada pada hujung ke hujung, maksudnya kita akan guna ml square over 3, and then mass equals to m equivalent 3, which is m equivalent beam, times with L square lah. Okay, L square. Then from here, L square potong, maksudnya M equivalent number 3 must be M over 3, which is M of beam adalah berapa? 30, isn't it? So 30 divided by 3. Kejap. M equivalent, sorry, macam salah ni. 0.8. Okay, saya silap. Kita kena ambil yang 0.8 dia bagi, which is IO, isn't it? 0.8, which is mass moment of inertia for beam B to D, which is IO 0.8. Sekejap saya padam balik. So kita ada IO sama dengan 0.8 sama dengan ml squared. Alright, M equivalent times with L daripada daripada point B, so ml squared. Alright, ml squared. So from here we can actually find what is our M equivalent for beam. So how to find it? We need to find the L first. How to find L? So based on equation of beam, which is we know that IO for beam equals to ml squared over 12, isn't it? So this is equation for beam lah. Mass moment of inertia for beam. Alright, a general equation. Jadi M untuk beam dia dibagi dalam 30, alright, times with L L kita nak cari bahagi dengan 12 sama dengan 0.8. Then L kita boleh dapat nilai dia sama dengan 0. Ataupun kita cari L squared lah, sebab kita nak masukkan L squared dalam equation. Jadi L squared is 0.32. So once kita dapat L squared, dan kita masuk dalam equation ni untuk dapatkan M equivalent for beam, which is 0.8 divided by 0.32, which is 2.5 kilogram. So M total should be 4 plus 16 plus 2.5. Then M total equals to 22.5 kilogram. Okay, clear. Then from here we develop our equation based on degree of freedom. C equivalent over M equivalent X dot plus K equivalent over M equivalent X equals to 0. Alright, then we can actually find our equation in terms of this value lah. Alright, so C equivalent, C equivalent diam, duduk. Sorry. So C equivalent 1.25C divided by M equivalent kita tadi adalah M total lah, equivalent to 22.5. Okay. x dot plus k equivalent 1500 divided by 22.5x equals to 0. Then compare with our equation of plus with 2 zeta omega n x dot plus omega n square x, isn't it? Equals to 0. Then from here we can actually find what is our omega n, which is set 1500 divided by 222.5. Okay, so 1500 bahagi 22.5 set, so 8.16. Alright, that is our omega n or natural frequency. Alright, once kita dapat omega n, then we need to find the zeta, isn't it? Kita nak dapatkan C sekarang kita tak tahu berapa, so kita boleh dapatkan C equivalent based on equation of 1.25C ataupun C equivalent kat sini, dapatkan C equivalent lah. C equivalent, mana C equivalent tadi? Okay, 1.25C. 1.25C divided by 22.5 equals to 2 zeta omega n, which is 8.16. Okay. Then from here we can find what is our C equivalent in terms of zeta. So ataupun C lah. C in terms of zeta. So berapa C? 8.16 darab 2 darab 22.5 bagi 1.25, 293.76. 93.76 zeta. So still tak boleh nak solve, dan kita kena dapatkan zeta dululah. So how to get the zeta? Based on equation, isn't it? Based on equation, jadi kita learn secara zeta guna ratio tu kan? Yes, guna ratio lah. So learn 1 divided by 50 sama dengan 2 pi zeta over 1 minus zeta square. Okay, learn 1 over 50 sama dengan negatif 3.912 sama 2 pi zeta over 1 minus zeta square. So, cuba dapatkan zeta berapa. Boleh kan? So pindah-pindah, kita akan dapat negatif 3.912 1 minus zeta square, kita squarekan dia 2 pi zeta square. Okay, then lepas tu simplifiedkan dia, kita akan dapat 15.303 1 minus zeta square sama dengan 39.48 zeta square. Apa dia soalan? XOXN tu value apa? Ni lah value dia, 1 over 50 ni. Learn X initial adalah 1, XN adalah 50. Jadi 1 over 50 for one complete cycle, for one cycle. Jadi N adalah 1 lah. Alright. N adalah one cycle. Alright, one cycle n equals to 1. So just put as 1 lah dekat sini sebab tu saya tak buat 1. So for one cycle maksudnya n equals to 1. So then lepas tu kita akan dapatlah zeta dia. So zeta lebih kurang sama dengan 0.5285. Okay, so once kita dapat zeta dan masukkan dalam equation, kita akan dapat C lah. Saya rasa jawapan tak sama ni. 293.76 5285 155, betul lah. Line, jawapan dia line 155.2. Tu jawapan kita. Kenapa line? Sebab based on jawapan dia bagi ni, dia consider K, saya rasa dah betul. Dia consider K equivalent sama dengan 1000. So kalau dia consider 1000 dan baru dapat jawapan 179. Sebab saya rasa memang K1 adalah 500 kan, bukan 1000. Ke saya yang salah? K1 memang 500 kan? Sebab kalau K equivalent 1 sama 1000, baru akan dapat 179. Sebab saya rasa memang K equivalent 1 ni sama 500. K equivalent kita darab 0.5 L K L square darab dengan L square. Jadi 0.5 square. Ya, betul lah. So sepatutnya jawapannya adalah 155.2. Alright. Ada soalan nak tanya? Any question? Faham tak ni? Macam mana kita nak transfer ataupun kita nak simplifykan our system tu, jadikan dia sebagai single system, which is C equivalent, M equivalent dan juga K equivalent. Boleh? Any question? Tak ada eh? Semua dah faham eh? Alright, so next question adalah kita tengok in this one. Okay. Yang ni panjang sikit. Okay. So soalan ni figure question 5 shows a system consisting of rigid body A or B, pivot at A, alright, supported by 2 springs and 2 dampers located on 2 uniform discs. This system is also loaded with 2 concentrated masses, and then determine resonant frequency of this system. Apa resonant frequency? So kalau biasanya soalan dia akan bagi term-term yang lain sebenarnya. Okay, so kena faham lah. So kalau dia beritahu resonant frequency, maksudnya omega n lah, ataupun natural frequency, sama je. Alright. And B, damping ratio zeta, C, period of vibration Td, D, amplitude ratio after one complete oscillation, A1 over A0, and then the initial frequency of the system. Okay, kalau dalam formula, kalau kita tengok formula A1 over A0 ataupun A0 over A1, based on formula mana? Okay, so formula adalah A0 over A1 atau AN lah kan. Jadi so kat sini kita kena dapatkan A0 over N dulu, and baru kita kena bahagi balik ataupun transfer balik. So kita tengok this one. First adalah kita nak dapatkan resonant. Macam biasa, first step adalah transfer all the mass K and C dekat mana-mana point. So dekat sini, point mana yang kita nak transfer? Which point yang senang nampak? Point A, you can transfer sama ada point A ataupun point B. You can transfer either you choose point A or point B. So let's say we choose point A, transfer all at A. Okay, transfer all at point A. Then what happen? We start with spring first. Alright, so spring. Where is our spring? How many springs we have? Kita ada 2 kan? So first adalah kita transfer spring for this one. Okay, this is number 2. So spring K equivalent 1 equals to 2880, isn't it? So still tak berubah, doesn't change. Betul? 2880 because they share same distance from pivot this one. Alright, 2880. So that is our K equivalent 1. And then how to transfer K equivalent 2? Since dia ada two pivot dekat sini, first ada pivot dekat this and another pivot at point O. Alright, before dia sampai dekat point A. So meaning to say that for K number 2, you need to transfer twice. First adalah you transfer K to point B first. Then once you got your K at point B, then transfer again our K to point A. So we transfer K at point B first. Okay. So transfer to B first. Alright, so for K2, kita akan ada K equivalent to prime. Alright, K equivalent to prime equals times with 0.2 square. Samalah sebab the distance sama kan. And then K times with 0.2 square, so sama same. So K equivalent to prime sama dengan equals to 2880 Newton per meter. Kalau nak transfer point K2 dekat A, only consider horizontal distance. Height 0.3 tu tak effect. Tak, dia bukan horizontal distance. Kita sekarang ni, kita nak transfer, kena tengok kedudukan distance from point of K to point of pivot dekat O. So distance ni kita akan ambil 0.4 dan juga 0.3. Dua-dua kita kena consider. Okay, tengok yang sini saya buat dulu. So first adalah kita transfer K equivalent to prime dekat point B. Once kita dah dapat point B, dan kita transfer K equivalent ni dekat A pula. So K equivalent to times with 0.3 square equals to K equivalent to prime dekat B sekarang ni. So kita darab dengan K equivalent to prime times with 0.4 square. Okay, dan kita akan dapat lah. We'll get K equivalent to, which is must be sama dengan 5120. Alright, 5120 Newton per meter. So that is our K equivalent. So K equivalent total sama dengan 2880 plus 5120. So K equivalent equals to 2880 plus 5120, 5000. So that is our first values lah. Okay, 5000 done untuk spring. And then kita focus on damper pula. Alright, we focusing on damper. Next adalah so C equivalent 1 equals to sama kan, 144 Newton second per meter. And how about C equivalent to sama juga, transfer C dekat sini first. C equivalent to prime sama dengan C, which is 144, and then C equivalent to times with 0.3 square equals to 144 0.4 square. Then we get C equivalent to must be 400, isn't it? Sorry, 256. 256. Then C equivalent total equals to 144 plus 256. Then our equation, our value of C equivalent must be 400. So that is our value of C equivalent. Okay, dah dapat C equivalent, dapat K equivalent, then dapatkan yang mass pula. Okay, mass. So how to get the mass? Sama juga, how many mass we have? Kita ada mass 1, 2, 3, 4, 5. So mass is very critical lah. So 5 benda kita nak kena buat. First mass adalah kita fokus on mass of beam. Okay, mass of beam. Okay, mass of beam, since dia bagi in terms of mass and K. What is K here, over here? KOB. Apa ni KOB ni? What is KOB? 0.2 meter. What does it mean? What is KOB? Gyration. Alright, so yes, KOB adalah radius of gyration. So maksudnya dia bagi dalam in terms of radius of gyration. Kita tahu AOB ataupun IO lah. Kita buat IO equals to MK square, isn't it? Okay. So kita dapatkan I dulu. M of AOB adalah 5 times with 0.2 square. Dan kita boleh dapat IO lah. So IO sama dengan tak perlu cari terus kot. So IO sama dengan 5, 0.2 square, that equals to M equivalent 1 times with 0.3 square. Okay, so kita akan dapatlah M equivalent 1. So this one for beam lah. Kita focus on beam, mass beam. So M equivalent equals to 5 darab 0.2 square bagi 0. Makin dah 0.3 square 0.2. So the value of betul ke ni? 5 darab 0.2 square bagi 0.3 square 2.22. Yes, correct. So 2.22 kilogram. Okay, 2.22 kilogram. So that is our M equation 1. Sorry, M equivalent 1. Alright, then lepas tu kita ambil yang M this 1. So how to transfer M this? M this M this 1 times with 0.2, isn't it? 0.2 squared 1 over 2. Betul? 1 over 2 equals to M equivalent 2 times 0.2 squared. Cancel out, then M this is given as 6.4, then we'll get M equivalent 2 equals to 6.4 divided by 2, which is 3.2 kilogram. So first here, and second M equivalent 2 for this. This is for beam. This is for this 2. And then next adalah we transfer M1. Alright, M1 adalah same. We taking our pivot dekat point D, this kat sini. Then M equivalent 3 times with 0.2 square equals to M1 times 0.1 square. Then over here kita akan dapat M equivalent 3 as M adalah 12.8 lah. So 12.8, 0.1 square divided by 0.2 square. So M equivalent 3 equals to berapa? 3.2 isn't it? 3.2 kilogram. So that is our M equivalent 3. So this is for M1. Okay, and then okay, then lepas tu for these two first adalah we transferring to point B first. So by taking M equivalent apa? M equivalent 4 isn't it? For prime times with 0.2 square equals to 1 over 2 M this 2 times with 0.2 square. So cancel out. Then kita akan dapat M equivalent 4 prime equals to 6.4 divided by 2 which is 3.2. But kita nak transfer M equivalent ni dekat point A. Then again we transfer again M equivalent 4 times with 0.3 square sama dengan 3.2 times 0.4 square. Alright. Then M equivalent 4 equals to 5.69, isn't it? 5.69 kilogram. So that is our M equivalent for this. So this is for this two. Sorry, this is this one. Okay. And last one for M2 again kita akan buat M equivalent 5 prime times with 0.2 square equals to M2 times 0.1 square which is M equivalent 5 prime sama dengan 12.8 0.1 square divided by 0.2 square equals to 3.2. Then transfer again untuk dapatkan M equivalent times 0.3 square equals to 3.2 times 0.4 square. Then we get M equivalent 5 must be 5.69, isn't it? Kilogram. So that is our M equivalent 5. So this is for M2. So once kita dapat semua, then our M equivalent equals to 2.22 plus 3.2 plus 3.2 plus 5.69 plus with 5.69 again. Sorry, 5.96. So M equivalent sama dengan 20, isn't it? 20 kilogram. So that is our M equivalent. Alright, so once kita dapat M equivalent, then masukkan dalam equation lah. So plus C equivalent over M equivalent X dot plus M equivalent X equals to 0. Okay, so then compare it with natural frequency equation lah. So X double dot plus 2 zeta omega n X dot plus omega, yes.
M equivalent 4 dengan 5 tu 5.69 ke 5.96?
Silap. 96 kan? Silap ni. 96. 69. Betul kan? 3.2
69.
69
Saya kira
kan?
69.
69 kat sini. 69. So jawapan betul 20.
Betul sir.
20 kan? 2.22 tambah 3.2 tambah 3.2. Yes, 20. So then compare it with 2 omega zeta n, then kita dapatkan answer frequency dulu lah. So omega n over K equivalent yang kita dapat tadi, where is that? This one 8000 divided by 20 divided by 20. Then our omega n is 20 radian per second. So that is our answer for question number A. Okay. For B, damping ratio zeta. So based on second equation, so 2 zeta omega n equals to C equivalent, which is 400 divided by 20. Then zeta equals to 400 divided by 220 omega n 20. So zeta must be 0.05, isn't it? 0.05. So that is our equation. That is our answer. And C, period of vibration. Alright, period of vibration. Then what is our period of vibration equation? Omega D equals to omega n 1 minus zeta squared. So omega D sama 20 zeta 0.5 bukan 0.5. Sorry, 0.5. 0.5. So 1 minus 0.5 squared times with 20. So what is our omega D? 17.32, isn't it? Betul? So 17.32 second. So bukan second, radian per second lah. Radian per second. 17.32. Then untuk dapatkan vibration of period T, D, so kita akan dapat TD sama dengan 2 pi over omega D, which is sama dengan berapa? 2 pi bahagi dengan 17. 17.32, betul? 2 pi. Betul equation 2 pi over omega D. So 0.36 second. So 0. Second. So that is our answer lah. Then D, amplitude ratio after one complete oscillation dibagi dalam bentuk A1 over A0. Sedangkan dalam equation kita ada learn A0 over A1, isn't it? So dapatkan this one first. Learn A0, betul tak? A0 over A1, initial to final. Tengok balik. Initial to final, yes. So initial to final. Then what is our formula? N 2 pi zeta over 1 minus zeta squared, isn't it? So N is 1 lah sebab 1 complete oscillation. So N equals 1. So learn A0 over A1 equals to 2 pi zeta. Berapa zeta kita dapat tadi? 0.5 over 1 minus 0.5 squared equals to 2 pi times 0.5 3.14 bahagi 1 minus 0.5 squared set 0.866 equals to 3.63, isn't it? So macam mana dapatkan A0 over A1 ni? Sama dengan macam mana? Nak transfer, nak akan jadi macam mana? Learn, convert to exponent. So exponent to the power of 3.63. So 3.6369 pula. 3.63. So the answer is 37.7, isn't it? 37.7. Since dia nak dapatkan A1 over A0, jadi A1 over A0 must be 1 over 37.7. So 0.027. So that is our answer lah. Okay. Any question? Ada soalan nak tanya? Tak ada? Okay, soalan E. Natural frequency of the system. If H equals to 0.2 pula. 0.1. Soalan apa salah ni? Betul lah. Kalau H berubah, saya yang salah. Kalau H berubah kepada 0.2, then what happen? What happen? If H is changed to 0.2 meter. So what is our natural frequency? M equivalent kecil. What is our natural frequency? If we change our vertical H tu kepada 0.2, dia berubah ke tak natural frequency? Bila tak kita tengok, we look at back our working stat over here, ada tak kita masukkan nilai H 0.1 meter dekat equation? Tak ada kan? So for this case, kalau kita ubah dia punya nilai H vertically, tak kisahlah kita kecilkan ataupun kita besarkan nilai H, dan our natural frequency dia tak akan berubah at all. Doesn't change at all. Because why? Because natural frequency is only depends on the value of M equivalent and also K equivalent. But for M equivalent dia tak berubah kan? K equivalent pun tak berubah. Alright? Unless kalau if we change our radius of this, and then dia akan berubah lah. If we change of length of OB or O to A, then dia akan berubah. Mana-mana parameters yang kita guna dalam working stat kita ni, then dia akan berubah lah. Sebab natural frequency must depends on M equivalent and K equivalent. So kalau kita ubah H pun, even this ni kita ubah dia ke atas sekalipun, dengan H, nilai H ni berubah 0.2 ke 0.3 ke ataupun 0.05 ke, dia still nilai nilai omega n yang sama. Alright, doesn't change anymore. Alright, dia tak akan berubah lah. So natural frequency of the system, if H equals to 0.2 meter, doesn't change, must be the same as what we calculated on A. Okay, any question nak tanya? Ada soalan? Tak ada? Semua dah faham kan? Okay, good. So kita tengok one more question. Alright, one more question. Okay, this one. The system in figure question 5 consists of apa ni? Consists of a crank lever AOBD pivot at the tak hilang pula. At the point O, alright, at the point O, a pulley and mass ME of 30 kg. The lever is attached to 3 springs and dampers. The mass ME is then displaced downward from equilibrium position and release. So determine the following: natural frequency of the system. Natural frequency of the system. So macam biasalah. So kita kena transfer dekat mana? Which point yang lagi senang nampak? Dekat D lah kan? So senang dekat D lah. So we transfer it to point D. Okay, so we start with spring first lah. Start with spring. So how many springs we have? So we have K equivalent 1. Okay, let's say this is mana ni? K. Yang ni K berapa ni? KC KA, KB, KD. So this is KD. This is KD. So K equivalent 1, kita start dengan KD lah. So K equivalent 1 sama dengan KD. Sama kan? So equals to 4000 Newton per meter. Saya guna ini. Sekejap. Okay. So transfer to D. Okay, so and then how about K equivalent 2? K equivalent 2. Yang ni kita ambil yang point B first. K equivalent 2 times with 0.4. This is for D. And mass equals to KB, which is 2000 times with 0.2 squared. Alright, so this is for B. So K equivalent to sama dengan 500. So 500 Newton per meter. Okay, and then last one, K equivalent for A. K equivalent 3 times with 0.2 squared. Sorry, times with 0.4 squared equals to KA. KA is 2000 times 0.2 squared. This is for A. Again, kita akan dapat nilai yang sama lah, which is 500 juga. And then our K total ataupun K equivalent total must be 4000 plus 500 plus 500. So K equivalent total equals to 5000 Newton per meter. So that is our first answer. Next adalah for damper. So for damper adalah C equivalent 1 equals to CD equals to 400 Newton second per meter. For C equivalent 2, for B sama juga, times with 0.4 squared equals to CB 200 0.2 squared. Then C equivalent 2 equals to 50 Newton second per meter. And then for A, C equivalent 3, 0.4 square equals to 200. 0.2 square, then we get the same answer lah, 50 Newton second per meter. Kenapa 0.4 dan 0.2? Kenapa 0.4 dan 0.2? Sekarang ni our pivot dekat point O, alright, dia berpusing dekat point O. So sekarang ni kita nak pindah yang B. Let's say we need to transfer B to point D. Then jaraknya daripada O ke D adalah distance for K equivalent, which is 0.4. Alright, untuk B pula, jaraknya daripada O ke B 0.2. Sama juga dengan A. Jarak C equivalent 3 from O to D adalah 0.4. And for CA from O adalah 0.2. So, sama 0.2, 0.4. So, C equivalent total sama dengan 400 tambah 50 tambah 50. So C equivalent should be 500 Newton second per meter. That is our C equivalent. Okay, next adalah M total. So M, we are given apa ni? IOD, which is IOD adalah 0.4. Ataupun kita ambil yang I mass puli dulu lah. For mass P. So for mass P 1/2 MP adalah 10 times radius dia berapa ni? 0.1. Sorry, this is diameter. So convert it to radius 0.05 millimeter. Kecilnya 0.05 millimeter. So 0.05 times 10⁻³ square equals to MP equivalent 1. Alright, equals to times with 0.05 times 10⁻³ square. So cancel out here. Then kita akan dapat M equivalent 1 lah. For MP equals to 5 kilogram. Okay. And then for ME. So for ME. So ME will be the same. M equivalent to sama dengan ME equals to 30, isn't it? 30. Mana ME? ME 30. So 30. And then last one, next adalah for MAOD. Okay. So we are given IOD, maksudnya IAOD equals to 0.4 mass equals to M equivalent times 0.4 square. Alright. So M equivalent 3 lah. M equivalent 3 0.4 square bagi 0.4. 0.4 darab dengan, betul ke ni? Sekejap. 0.4 bagi 0.4 square 2.5, isn't it? 2.5 kilogram. And last one, MA kan? So MA. So for MA kita nak transfer ke point D, then using pivot O sama jugalah. So MA times with 0.2 square equals to M equivalent 4 times with 0.4 square. Then M equivalent 4 equals to 2.5 kilogram. Jadi M total equivalent must be 5 plus 30 plus 2.5 plus 2.5. Jadi M equivalent equals to 40 kilogram. Alright, then once we get M equivalent 40 kilogram, ME jadi 30. Kenapa ME jadi 30? Sebab sekarang ni ME ni dia hanya bergantung kepada, kalau kita Okey, kalau saya buat, sebab ME ni dia punya pivot point dekat MP, dekat puli kat sini kan. Jadi sama juga saya buat ME darab dengan distance, radius dia 0.01 times 10 to the power negative 3 square equals to M equivalent to 0.01 times 10 to the power negative 3 square, dan cancel out, dan kita akan dapat yang sama, betul? Kita akan dapat jawapan yang sama. So ME ni dia akan sama dengan M equivalent, which is 30 kilogram. Is that clear? So once kita dah dapat M equivalent, then kita kena transfer lah macam biasa, using equation. So X double dot plus C equivalent over M equivalent X dot plus K equivalent over M equivalent X equals to 0. So kita ada X plus compared with 2 zeta omega n X dot plus omega n square X equals to 0. So omega n sama dengan cert K equivalent 5,000 divided by 40. So berapa omega n? (11.1), isn't it? 11.18 radian per second. So that is our answer lah for the first one. Number 2, period of vibration if there is an oscillation. So nak dapatkan period, dapatkan zeta first. So 2 zeta omega n equals to 500 over 40, then omega n must be, zeta must be berapa zeta? 0.559, isn't it? So dah dapat zeta, dan dapatkan omega d lah. Omega d equals to omega n 1 minus zeta square. So omega d equals to omega n is 11.18 1 minus 0.559 square. So omega d sama dengan 9.27. So what is our TD? TD berapa formula dia? Sekejap, saya confused. Betul lah, TD omega 2 pi over omega d lah. So TD sama 2 pi over omega d 9.27, sorry, 2 pi over 9.27, dan berapa TD? 2 pi bahagi 9.27.
0.68.
Yes, correct. So 0.68. 68 second lah. Okay, ada soalan nak tanya. Okay, nombor 3 tu, apa maksudnya? What does it mean? Damping constant for the system when it reach critical condition. Apa maksud? What does it mean here? Damping constant C for the system when it reach critical condition. Apa hint yang kita boleh dapat when critical condition? When critical condition maksudnya zeta equals to 1. Okay. So C equivalent over M equivalent sama dengan 2 omega n zeta lah. So C equivalent over 40 11.18 times 1. So dapatlah C equivalent sama dengan 894, betul? 894.4 Newton second per meter. Okay, done. Dah siap dah. Okay, boleh? Ada soalan nak tanya? Satu lagi soalan ni pasal apa ni? So, boleh tengok balik kod. Lebih kurang je soalan dia ni. Okay? Any question nak tanya? Cukup 3 soalan. Cukup lah tu. Aku 10 dah ni kan. So, lepas ni boleh try buat sendiri. So, sebenarnya soalan yang saya bagi ni adalah final year punya previous. Kena try dulu. So, nak harapkan saya memang tak boleh juga kan. So, you need to kena buat juga lah. You need to